So welcome back to the 9th lecture in the R series, and today we'll talk about another utility in R. So R Markdown essentially is a feature which is provided with R Studio, and this basically allows you to document your program better and also generate a HTML or a PDF format of the program along with the output. And you can divide your program into chunks and get the individual chunks can be played, and the output of the individual chunks can be displayed right on the terminal and also can be taken as part of your printout. You can also publish your R Markdown program on the site. Let's get started and we move to R Studio. Here we are into R Studio, and of course you remember this is a scripting area here. This is your console, the standard input-output terminal. This is the environment variable area where you can see what variable you define, what is its nature, and what is the type of value that it has. And then this is your general purpose area where you can have your viewer, you can have your help. You could look at your packages. If you want to install a package, you could install a package from here. You can look at your plots when you do your plotting, and we'll do that in a lecture very soon. And then of course you could look at the files that you have uploaded here. So this can take you to your folders where you can see your files and so on and so forth. So let me keep it to a rear view because it's more neat. And now if you see, we also come back to the classical R Studio settings. So here you are. If you're opening the document for the first time to start writing, you will say new file, and in new file, you will say R Markdown, right? So this is your option that you have to select. When you say R Markdown, a document will open for you and it will ask you the title of the document. So you could give it any title. Let's say I give a title called DNA 1, right? And I say OK. So now what this is going to do is to open me a document. This is called the R Markdown document, where you have the title pre-written. This is DNA 1. The output is the HTML document, and it also gives a date to your document. So this is basically to document when the program was written, how the program was written, and also the output and everything would come with it. And then if you come down here, it says R Markdown. This is an R Markdown document. Markdown is a simple formatting syntax for authoring HTML, PDF, and MS Word documents. For more details on using R Markdown, you have a website that is given. This is rmarkdown.rstudio.com. Right? And then, of course, when you click on Net button, a document will be generated that includes both content as well as the output of any of the embedded R code chunks within the document. You can embed an R code chunk like this. So if you see here, this is the way of embedding an R code chunk. So basically your program is divided into various parts. These parts can be called as chunks, and one specific part can be actually coded like this. So you can start a block by specifying 3 commas here. And this is a special comma that is basically present on your QWERTY keyboard on the second row, the first button, right? And this is also shared by the tilde sign here. And then, of course, if you go back here, you can start your curly brackets, and in curly bracket, you can write R and close the curly bracket. And then, of course, you could give whatever command you want to give in between. When your chunk of the code is complete, you just close it by, again, putting the same 3 commas here. So this part of the program, that is a chunk of a program, would come in like this. And here, if you see in this chunk, you have 2 buttons. This button will basically, if you click on this, it will say run all chunks above. So all the chunks above this part of the program will be run before you can run this. And the second button is the play button here, and this is basically to run the current chunk. So you could selectively run the previous chunks, or you could run the present chunk, right? In the area between 2 chunks of the program, you could write anything. So this part that is not present in R chunks will not be executed anyways. To start your document, what we do is we clear out everything except the first part and then get started. So we delete this, and now we can create a R chunk here. So I'll say comma, 3 commas, and then in the bracket, I'll say R, right? And then, of course, I have to close this at some point of time. So there again, I'll give 3 chunks. So now if you see, I've created a part of the, I've created a chunk of the program where I can give my instructions, and that can be followed. So let me first write what the program is about, and then of course you can go forward and keep programming here. So let me write function to calculate area and volume of a cube, right? So this is what you're doing, and sorry for the typo here. This is what it is, right? So we start with the first chunk of the program where we're defining our cube function. So remember, for a function, you must have a function name. So we'll call it cube, and we say cube equals 2, and then we define the keyword that is function, which is basically to state that this is a function that you're writing. So function function, and then in these round brackets, you have to give the function argument, and a function may have an argument, may not have an argument, but mostly the functions would have arguments because it will take some input value, process it, and bring out the result. So for calculating the area and volume of the cube, the only thing that we require is the length of one side of the cube. So we'll give the function an argument called length, length 1. Remember, length is a keyword in or a function command in R. So therefore, length cannot be used. So what we use is length 1 here. So then we move on and we calculate the area first. Area, if you remember, would be 6 into the length 1 squared. So that is what we're going to calculate here. So area underscore cube equals to 6 asterisk length 1 raised to power 2. So this is the caret sign, and we say 2, right? And then we calculate the volume of the cube, and volume of the cube will be VOLUME, volume underscore cube equals length raised to power 3. And then, of course, we would want to print these values. So we can print here, and for print, we can use a vector. So we say print, and we see C combine, and we first say the length 1, length 1, comma, area underscore cube, comma, VOL, volume underscore cube. So it prompts you the variable name, and you could do that. And then, of course, what I forgot here is you have to open the curly brackets here. And then, of course, once you're done with the function, you have to close the brackets. So we close the bracket here, right? So this is our function now, properly defined. So remember, a function has 4 parts. One is basically the name of the function. Second is the keyword that is used to define a function. So this is actually function in case of R itself. Then you have the arguments here, which is depending on what is the functionality that you're giving. There could be 1, 2, 3 or more arguments. Technically, you could have a function that does not take any arguments, but usually a function would take an argument that would be processed and an output will be given. And then you have the body of the function where you actually operate on the arguments that were given to the function and basically take an output or a return value. So this is our return value here. And then, of course, you close the function. So this is basically function, and you can look at my actual video on functions, which is, I think, lecture number 7, where I've clearly defined what all is required for a function, right? So then this is ready now, and we can move on. And if you want, we could run this part of the program to see if everything is fine or not. So let me just run it. So remember, there is nothing before this, so we don't really need to use this switch. This switch is to play the part of the program that is before this, run all chunks above. And this one here is to run the current chunk. So we run the current chunk. And of course, you see there is, because there is nothing that has been given as a function yet, so therefore you don't have anything coming up here. And there is no error report also, which means that this part of the program is running fine. Now we come to the second part where we'll now actually call the function with arguments and take the results. So now you come out of the code. When you press enter, you come out of this chunk. Now we create the second chunk. So before that, let me just comment this. So calling a function. So now we're going to call a function and see how it works. And now again, we'll open a second chunk. So for opening a chunk of the code, you say this and you say R in curly brackets. And then wherever you want to close, you can just give again the 3 commas. Right? And that will close the part of your chunk. So now your chunk is ready where you can now write your instructions. So what we're doing here is a simple thing. We're just going to call the cube function and calculate the area and volumes. So we are now calling the function cube. So you simply have to mention the function name, and then also because there is an argument that has to be given here, you could give an argument. So let's say we have a 4. So our length of the each side is 4 centimeters, right? And so therefore now we can run this directly and see whether it works fine or not, right? So here you are, you run this. So when you run this, the output will be shown here itself. And if you see now, when you actually run it, you realize that there is a mistake here. Length is not the one that we defined. We defined length 1. So this has to be corrected, right? So now that we have an error, we need to clear out the previous run so that there is no collision with what has been read previously. So we'll clear out everything here. Let me clear this here, and let me also clear this here, right? And now we run the chunk one more time. And we could cross-check one more time so that there are no more errors. So cube equals to function length 1. And this is the argument that we're giving. And then area of the cube is calculated as 6 asterisk length 1 raised to power 2. And volume of the cube is calculated as length 1 raised to power 3. And then you're printing the values by creating a vector which contains values length 1, area of the cube, and volume of the cube, right? And so now we run it one more time. And so now we call the function again. So now we come to the second part of the chunk. We've already run the first part of the first chunk, and we do not get any error messages, although last time there was an error. Now we come back to the calling the function, and we say cube, and we give the value of length as 4 centimeters, let's say. And we run it one more time, right? Here you are, the results. The length is 4, the area is 96, and the volume is 64. Right? So this is the advantage with R Markdown. You will get your output right below the chunk of the program that you've written, and that makes it a lot easier to view and a lot easier to understand. And one more thing about the functions that you should know is that you can also define your default arguments. For example, here I can write length 1 equals to 1. So even when I do not give an argument while calling the function, it will take it that the default argument that is given is the value for the length and calculate the area and volume as per the default argument. So here we are now calling the cube function without giving any arguments, but in the actual function we've defined that the default argument for length is a value of 1 centimeters, let's say, right? So we come back here. So we run the previous chunk using the triangle pointing downwards. So this one is the one, you run it. And now you give the current command here, which is we are calling the cube function without any arguments, which means that the default argument of 1 centimeter would be taken as the actual length of the cube. So if you have a cube of 1 centimeter side, then you know that the area is 6 into L squared. So it will be 6 centimeter squares and the volume would be 1 centimeter cube. So now we run this part here, and if you see, you get the results here. So this is your result. 1 is the length of the side. So this one represents the length of the side, 6 represents the area, and 1 represents the volume of the cube. Right. So if you remember in the previous lecture on R functions, I had taken a loop and varied the value of the length 1 parameter from 1 to 10. So we'll do that again here. So I create another chunk. So how to create a chunk in an R Markdown program, you know now. So you take these commas here, and then in curly brackets, you say R, right? So you've created your chunk, and then of course, to close the chunk, you just have to again say 3 commas. So this is our area now. You can already see there is a button to play the previous chunks, and there is a button to play the current chunk. So what we'll do is we are going to now create a for loop where the values of the for loop will vary from 1 to 10, right? And so let's say for I in 1:10, right? And of course, you open the bracket here, and then you bring down the bracket that is closing here, right? So, and in between the two, we give our command. So we are going to call the cube function. So we say cube, and as an argument for length, the value that we give here is I, right? So this is your I value here, right? So this is basically the value of I will keep changing from 1 to 10. And because we call the cube function, it will take the value of I from initially in the first round 1, then 2, then 3, 4, 5 until 10, and give you the actual areas and volumes depending on what is the length of the cube that you've given, right? Here you are, and we can now play this chunk and see if everything is going fine. And here is the output here. So if you see in our Markdown, the output for every chunk will be given next to the chunk where the code is written. So if you see here, when the length is 1, the area is 6 and the volume is 1. When the length is 2, area is 24 and the volume is 8. And when the length is 10, area is 600 and the volume is 1000. Coming back to the utility of Our Markdown, you can generate beautiful working documents here. So you say net, and when you say net, it is going to generate an HTML document for you, right? This will come up. If you see, this is rendering, and you can see the circle is moving here, right? And here is your document. So here is the HTML document for the program you've written. The name of the program is DNA1. This was created on 2nd June 2022, which is shown here. And then you have the first comment, that is function to calculate area and volume of the cube. And then you have the actual code for this region, the first chunk that you created. And then, of course, you have the second comment that is calling a function. And here you're calling the function without giving an argument. And this is the output for that, because the default you have defined length equals to 1. So the output is the length is 1, the area is 6 centimeters squares, and the volume is 1 centimeter cube, right? And then this is the second chunk of the program where we wrote a for loop to vary the input value from 1 to 10. And then when this is your input, here is your output for this chunk. So this is the advantage. You can create a very nice, workable, and visibly beautiful document that can be stored and saved and can be used later as a reference. You could also publish this application or document. So let me just close this, and let me show you also how, if you see net, you can say, you could also say net to Word. So if you net to Word here, it is going to create a Word document now, right? So here you are. So basically, R Markdown helps you document your program well, also divide your program into clean chunks, and this also helps you and debugging more efficiently. So we close here, and then we'll talk more about the genome analysis in the next lecture. Please do like and comment in case you actually like the tutorial. Thank you.